Good morning, afternoon, ladies and gentlemen. We are going to jump into section 7.5 via video because I'm at home as usual with a sick kid as usual. I love them just as I love you, except more so because I'm willing to make lesson videos for them when they're absent from school. So hope you guys can enjoy this. You should have a copy of these notes, 7.5 exponential functions. You should be on this side of them. We're going to do the back in a separate video. And as is always the case, follow along, give your best effort, and do not hesitate at all to ask the sub to pause the video at any moment if you need to see something twice or just at a slower pace. And I will also be sending out links via Remind so you can watch both of these videos on your own time if you have to watch them again while you're at home tonight. Let's jump into it. An exponential function is any function that looks like y equals some number a times some other number b to the x power. And that to the x power, the fact that the exponent is a variable, that's what makes it an exponential function. Now, these functions are pretty interesting. They actually show up a lot in life. We'll talk about that in a day or so. But when we're looking at the basics, the domain and range, the domain is going to be all real numbers. You'll remember this symbol. And the range won't be all real numbers, but it's usually pretty easy. Most of the time, about 2/3 of the time, it'll be all y values that are greater than 0. So remember, domain, if you need to write all x values for domain, that's going to be all real numbers. This thing's going to go all the way to the left of your graph, all the way to your right of the graph, forever and ever. But for the range, it's only going to go so low as 0. It'll shoot up forever, so y can be greater than 0, but it won't go down forever. It'll stop just before it gets to 0. It'll never actually touch 0. Now, I will also add that it will sometimes be greater than a different number. We call that number k, and you'll figure out why as we get deeper into Algebra 1. But for right now, just know there are some times where it's not going to be 0. It'll be k, and we'll do one of those examples. X-intercept, as always, it's going to be the point when x equals 0. And so you would just plug in 0 into the equation and see what you get back out. It will oftentimes be whatever a is, because if you think about it, b to the 0 power is just 1, and so all you have left is just the a. But that'll change sometimes depending on what the problem is. So again, for the most part, it's going to be a. For pretty much every problem that we're going to do, it'll be a. But you can always plug in 0 in your graph, and you'll even see right away, oh, there's an example where it's not, because there will be some in the homework where it's not. Okay, let's try one of these and see what it comes out to. We have y equals 3 to the x, and because it's 2020, we are not going to make this table by hand. We're going to have the calculator do it for us. So y equals, clear everything out. Okay, we're back here in the graphing menu. First equation, 3 to the, remember that's the caret key, 3 to the x. And that's it. It's typed in and you can graph it. Now, as it draws, it's going to make kind of this weird shape. You're not going to see anything here, but there actually is graph there because remember, the graph goes all the way to negative infinity. It's just so close to 0 that you can't see it. But then once it gets over to about -2, then it starts to shoot up and then it goes really fast. It goes up really quickly. There is graph all up over in this region. It just doesn't show up on the calculator. So we're going to get the actual points for this with the table function. Press your second button and then table right here above graph. And you'll notice here, these negatives, they give us decimals, right? They're not the ugliest decimals, right? 0.1 repeating, that's 1/9 as a fraction. 0.3 repeating, that's 1/3 as a fraction. We're going to have to estimate these. In a section that's mostly about graphing, when you start seeing the decimals, understand you're just going to do your best. But what we're really looking at is things like 0, 1, x is 0. There's my y-intercept. And then 1, 3, 2, 9, like these are much easier to graph and they'll give us enough to see the shape of what we're looking for. So we're going to copy these down over to the table, -2, -1, 0, 1, and 2 for our x values. And since I know these ones, we'll write them as fractions. 1/9 for 0.1 repeating, 1/3 for 0.3 repeating. That's kind of hard to see. And then 1, 3, and 9 for these ones. Once we've got those in the table, then we can graph them. Again, the negatives, those ones are tricky. Excuse me, background sound, janitors are working hard. Negative 2.1, negative 1.3. And then right here, 0, 1. Okay, that's our y-intercept. And then 1, 3. And note, these are going up by 2s because with exponential equations, they get big really fast. So you kind of have to adjust your scale, go up by 2s, go up by 4s, depending on the problem. So 1, 3, and then 2, 4, 6, 8, 9 should be right about there. Again, just do your best. But then when we connect those dots, you'll see we get this little flat line down here, and then it's going to scoop up really quickly like so, okay? Now, take a moment if you need to, pause on that one, and we're going to try this next example. This one's different. You'll notice right away that now we've got a fraction. And fractions are actually pretty important because they're going to flip the shape of the graph, but it doesn't change what we do to solve anything at this stage. So go back into y equals, just like we did before, clear out the old one. Just like we talked about in previous sections, anytime I got a fraction, put it in parentheses, 1 divided by 4, close parentheses, to the x power, and graph it. And now you'll see here it starts really high on the left and then does that really small thing where it gets real flat and it kind of disappears, okay? This is called a decay function versus the other one being called a growth function. We'll talk about those more tomorrow when I see you guys again, hopefully after the weekend. But the thing I need you to understand from here is the graphing part, even though it looks different, the same process applies. Press second, press table, and then plot your points. The only difference is now the negative numbers give me prettier numbers, right? So negative 2, 16, and negative 1, 4, and 0, 1. And then once after I cross the other line, now is when I get into the uglier decimals, right? So 1 and 0.25, you probably know is 1/4, but it doesn't really matter. 2.0625, that's 1/16, but again, we're not going to worry about that too much because we're just worried about graphing. Once I've got that, I just plot my points. Negative 2, 16, 2, 4, 6, 8, 10, 12, 14, 16. That's why it's nice to have the scale go up by 2 here. And then negative 1, 4, 0, 1 again. And then it trickles down. Okay, just like that. Connect the dots, and you're golden. Okay? All right. Now, I want you to take a quick moment, and I want you to see what you come up with for this third example here. See if you can get that one typed in your calculator and see what comes up. Okay, so hopefully you've got that typed in. Sorry for that weird gap, but I had to close my door. This has really turned out to be my best video ever. I hope you guys are enjoying this. We're going to type this in just as we did the other ones, right? So parentheses, 1 divided by 3 to the x power. And then it kind of works out where we just do the +1. So, this one, while it could be tricky, actually doesn't have any tricks to it, right? We don't have any extra sets of parentheses we have to add in. So hopefully you guys were able to type that one in the same way I did, and have it match what I did. If not, again, pause, make sure yours does match mine before the sub moves on. Cool. Second table. I'm sorry, not second table. Let's do graph first. And again, it's a fraction, so we start high on the left again, but now you'll notice instead of it hitting the x-axis and kind of disappearing, now we just kind of get this flat-looking line. And I say looking because if I could zoom in close enough, I see it is still sliding down, but it pretty much is going flat. And the reason it's up higher now is because of this +1. Now, if we go back up to the top, remember I talked a little bit about how the range is going to be mostly y is greater than 0, but sometimes y is greater than k. Well, here we have one of those k values. So this is a good problem for us to really focus on domain and range. I kind of skipped on the previous two problems, but we can really look at it here. Let's go ahead and get the graph first. Second table. And again, plot the ones we can, right? This doesn't go up to 28, only goes up to about 18, which means I can graph x negative 2, y 10. So we'll start there. Negative 2, 10, and negative 1, 4. And then 0 is now 2 instead of 1, which is interesting. And then now I'm getting the decimals, but they all have the 1 in front, because it's 1 and 1/3, 1 and 1/9. So now my horizontal line, that little line it's going to kind of get close to, it's happening more here. And as we get into Algebra 2, we'll learn about what that line is called. It's called an asymptote, and I'll hold you guys more accountable for it as we get, further into your math careers. But for now, I just want you to be aware of it, right? It's this horizontal line that we're never going to touch. That's what the asymptote is. And a lot of times it's just the x-axis, but sometimes it's a little bit higher, and that's when this k value is present, right? Anytime we have a +1, a -3 over here, it's going to move this graph up and down. And I want you to just try your best to account for the fact that this graph starts high and flattens out, or if it's reversed, it's going to start flat and then shoot up. Now, we haven't talked about domain and range since the definition, so let's make sure we do it for here, right? The domain, as we've said, is always all real numbers, okay? And then the range is going to be y is greater than k, whatever we're adding onto the outside here, which again, usually will be 0, but in this case, it's y is greater than 1, okay? Now, before we end this video, I do just want to click back real quick. Speaking of the range, here, the range is y is greater than 1, right? Range, y is greater than, I'm sorry, I said 1, 0. It's getting close to 0, but never touching 0, okay? Y is all the values greater than 1. Goes up forever, goes up to infinity, but it stops just before 0. It never gets any lower than that. Same thing with this other example. Shoots up to infinity, but then stops just before 0, okay? All right. That should be good enough to get started. What I want you to do is take a break from videos. I want you to take the next 10 or 15 minutes and try the first 4 problems of the worksheet. Subs will be able to pass that out to you. Do your best, right? Give your best effort. And if you have questions, write them right there on the homework, and I'll collect those and discuss those next time I see you guys. All right. Thanks for watching. We'll see you in the next video.